For the last lecture of day 3 and lecture 12 overall, we have generative AI and quantum computing delivered by Professor Gautam Makwana.
Now, this is a both two different domains, generative AI and the quantum computing. Today, I will try to finish the generative AI and the quantum computing I will take on the Friday. Okay. If I take the both the topic in the one a day within 1 hour, then it is very difficult to cover for me because both the subject are the wide areas. Okay. If the time will permit, then I will complete the quantum computing also. That is the first we will take about the generative AIs. Okay, the agenda will be the introduction, evolution of the generative AI, methodology and the architectures, application of the generative AI, ethical, social, and the economic implication of the generative AI, and the quantum computing concept and the quantum computing learning. Okay, that will cover in the my this lectures. And before this one, these are the my acknowledgement to the all the contributors regarding the generative AI and the quantum computings. Okay, now what is the generative AI? Okay, up to now we start with the machine learning, AI, deep learning, then large language models. Okay, now it is another area of the AI, that is the generative AIs. Now, main use of the generative AI, Madam, please. Main use of the generative AI is to enable the machines to generate the high fidelity text, images, audio, and the structural data with the unprecedented realism and diversity. Generative model learn the underlying probabilistic data distribution to the synthesize the new and the current output. Generative AI led to the revolutionary application in NLP, computer vision, scale, and the autonomous system and the scientific discovery. The main is to create the new contents of any domains, either in the text, image, or videos. Okay, so here for me to create the new content, I require the many qualities. Then and then only I can generate the new contents. Okay, so this is possible because it is not easy to create the new content in the different contexts. Okay, any person can create the new content only on his or her expertise, but we are making the machines to create the any kind of the new content of the many contextual point of views. Okay, so this is a known as your generative AIs. Okay, so here mainly is a why this generative AI is possible, because of the technological advancement in the every domain, like the mathematical advancement, the availability of the large scale data set, because every person are having the different context. Okay, so we need the large scale data set, pre-trained state of the art of a model. So because of the already GPT or Chat GPT or Llama, all are the large scale large language model are available. Well established AI learn model, correlation and the characteristics of the large data set, advancement in the hardware, the CPU, GPU, memory size are in the big number now. Availability of the cloud-based computing infrastructures. If I don't have the GPU here, then I can take the service of the cloud to produce my generative AIs. Availability of the open source software and the advancement of the deep learning model like VAE, GN, diffusion model, and transformer based architectures. And because of this, generative AI are available. Today, every day, you are seeing the different kind of the videos of the political point of view, because right now there is some election in the nearby future. So there are the many kind of the video are going, and this is because of the generative AIs. Okay, now so these are the applications. Okay, these are the application image outpainting, image captioning, chat box, text to speech, AI art, and the metaverse. Okay, so you can get the text, images, and video. You can create new contents depending upon the context of the requirement. Okay, so these are the some of the applications. Now the evolution of the generative AI. So here we will discuss the uh, key contributions, strength, limitations, and the model and architecture, and the training challenges. Now first, because of the in the 2006, so, model and the architecture are the RBM, restricted Boltzmann machine, and the deep belief network. That is the main contribution is the early probabilistic generative model using the energy based learning, and the strength is the hierarchical feature learning, and the limitation is the training instability and the scaling issue. Then there is a new kind of the model that is non-aerial variational encoder that we will discuss in the next slide. What is this actually? And then it is the probability threatened space representation. The plus point is the efficient training structure and the latent space, and the limitation is a blurry sample generation due to the Gaussian adaptation addressed in the hybrid like VAE and GEN. And 2014, generative adversarial network is evolved, and because of this, it is a we can make the adversarial training for the high fidelity generation. High fidelity image generation are the key point strength of this algorithm, and the limitation is the mode maybe the mode collapse, adversarial instability, and it is the sensitive high parameters. 2015 to 18, it is a deep convolutional gain, sustained gain, progressive growing. These are the combination of the convolution deep CNN with the gain. This is the cascading of the two different algorithms during the 2015 to 2018, and a key contribution is the stable gain variant and the cell-based generation, domain-specific application like the face synthesis. The strength will be the high resolution, diverse output, fine control, and the style gain, and the limitation is sensitive to the hyperparameter, high computational cost. Then the 2017 GPT and BERT, and here it is the periodization, long range context modeling, and the limitation is the high training cost. BERT is not generative by the designs. And 2020 diffusion model, and here is the strength is a robust probabilistic framework, high quality output, and the limitation will be the slow interference, requires significant computational property resources. And then it is a 2021 to 2023. Okay, it is a multi-modal generative AI, multi-donor generative AI. Frame નથી આવતી. So it is your constructive language image pre-training CLP, and then it is the integration of the text, images, and the audio generation. And in 2024 to 25, there is a new kind of the model. There is the CM and the SDXL. That is the consistency model and the stable diffusion. Here the plus point is the efficient interference, photorealistic output, and multimodal scalability. Training complexity are the limitation, high computational cost, ethical concern in the video synthesis. Now, the what kind of the architectures used in the generative AI? So there are the mainly three kind of the architecture. One is a variational autoencoder, then it is a generative adversarial network and transformer based generative model, and the next one is the diffusion model, and it is also the hybrid architectures. Okay, these are the just a few. This is the variational autoencoder, generative adversarial network, and this is your transformers. So yesterday I talked about the autoencoders. If you remember, it is a autoencoders. So here in the autoencoder, uh, input space are transformed into the low dimensional space. Okay, and then with the help of the low dimensional space, it will the input are reconstructed again at the output. At the time, the input and output are both are same, but it is based on the encoder and decoders. Encoder is the number of the input, and at the output of the encoder, it is the rest number of the input. There is a encoder autoencoders. Now here it is a variational autoencoders. Variational autoencoders. So here in this case, what happened? The input are converted into the latent variables. Latent variable are the where the it is a providing the probability distributions at the encoders. So in this case, here, at this case, this is my input X, and the output is the Z. This is my encoders. The output Z is the probabilities output. In the autoencoder, only the my output are the dimensional reduction of the your input. But here it is a output is a dimensional reduction, but having the probabilities distributions. So here it is a this Z are having the what to call mean and the variance. Mean and the variance are kind of the this thing. That's why it is known as your latent variable representation. So here the VAE introduced a probabilistic latent variable representation. VAE map input data into the latent space where each input corresponding to the probability distribution rather than a single point. Okay, this enables the meaning sampling, structure interpolation, and the smoother generation of the unseen data. So here it is a advantage. If you add a latent variable representation of the your input data, that is a that so from this probability distribution, we can able to generate the unseen data during the encoder passing of the your data. Okay, so this is the your even we can make the interpolations. Interpolation are used to generate the your new contents. Okay, so here assume the Z is the stochastic latent variable that serve as a compressed representation of the your input X, capturing the essential structure in a lower dimensional space. So this is the your advantage to convert the your input into the latent variables that will help to making the possibility of the interpolation and the generation of the unseen data during the encoder. Earlier in the autoencoder, we are we are doing the training on the autoencoders. But here we are making the what you call we can identify the interpolation data as well as the generation of the unseen data during the training point of views. So that is the use of the variational autoencoder structures in the generative AI. This allows the VAE to learn smooth transition between the similar data point, leading to the meaningful interpolation between the generated samples. And this stochastic nature of the Z ensures the small variation in the input data do not lead to the rigid reconstruction, but instead produce the diverse, realistic output. This allow to sample the different possible value of the Z leading to the variable in the generated output. Now, in the same way, this from the this Z, it is a reconstruction of the your data at the your decoder point of view. Decoder will by the using the your this sample return variable, it will the reconstruct the your data, or it can be the generate the new contents. Okay, in the autoencoder it is a reconstructions, but here it is a variational autoencoder because of the this because of the return because of the property of the return variable, you can generate the new new contents based on the this return variable in the case of the decoders. Now this is the your, so here both the encoder and decoder are having the probabilities distribution natures. Generally encoder and decoder are not having the probability distribution. Here it is the probability nature of the encoder and decoder that is known as your variational autoencoders. So that is a difference in the autoencoder and the variational autoencoder, and that is used in the generative AI. Now, this is just given the idea about the how the autoencoder and the decoder can having the given the input X, the encoder parameterize the posterior distribution over the return space Z, and this is given by the this equation where the sigma x square and mu 0 are defined the variance and the mean of the return distribution, and the I is the identity matrix. So here is the X is the input and Z is the output. Okay, this equation will give the, and this is given the Gaussian distributions. This define the Gaussian distributions. Okay, so this variational autoencoder use the Gaussian distribution in the probability distribution, and the decoder will function the phi f theta of Z parameterized by the theta, reconstruct the X from the return variable Z, sample from the q theta of the Z given the X. The probability distribution of the X given Z is given by the this. So Z is the input and X is the output. So for given Z, what will be the X? It is the estimation or generations depending upon the Z, and the depending upon the this probability nature of the this X f theta of Z and the sigma square and the I. Okay, now to train the VAE, what will be the objective function? Objective function will be the maximize the evidence lower bound, that is known as your ELBO. So this is the during the training, this should be the objective. The function should be the maximize the evidence lower bound, which is given by the this equation, and by the this is the your Kullback-Leibler divergence DKL act as a regulator, enforcing that the running rate distribution remain the close to the prior P of Z, typically a standard Gaussian 0 and 1. Okay, to enable the back propagation through the stochastic latent variable, reparameterization trick is applied. That is given by this equation, and this is a VAE provide a structure generative models because of the probability distribution, and they often produce the blurry reconstruction due to the assumption of the isotropic Gaussian trial in the latent span. Okay, so this is the one drawback about the VAE in the generation of the it is a generative model to generate the new contents. Now another model is the generative adversarial networks. Generative adversarial networks. So here it is the with the help of the input, original input, the dummy output is the produce, and both are compared. Both are compared. So this is the generative is a generators Okay, to learn the underlying the distribution from the which the data sets come from, and the adversarial is to compute the network adversary, the reverse. Okay, that are trying to beat. They are trying to beat the each others. Here, X is the input, and based on the written space, generator will be the produce the dummy X, and the other discriminators. This dummy X generated by the generator and the original data are compared, and it is classified that it is the real or fake. It is a real or fake. That kind of the structure is known as your generative adversarial networks. Okay, and here the job of the generator is uh, uh, the function of the generator aim to minimize the this function by putting the discriminator into the classify the GFZ. So here the GN employ a adversarial planning framework for the objective function V D comma G consisting of the generator G and the discriminator D. The generator map a return variable Z sample from the prior distribution to a generator output G of Z equal to X prime, that is this part, and the discriminator attempt to classify the whether a given sample is real or generated or fake. So here it is a comparison of the discriminator is compared whether the generated output uh, generated sample is whether it is a real or fake at the discriminator. So V of D comma D measure the how well the discriminator D distinguish the real data from the generated data. The discriminator aim to maximize the V of D by G. The aim of the discriminators aim to maximize this function by correctly classify the real sample X that is equal to your P data of X as a real and generated sample G of this as a fake. So here the main aim is to maximize this function that the real data will be the classified as a real and the X prime is data classified as a fake. And what is the aim of the generator? The generator aim to minimize the V of D comma G by putting the discriminators into the classified G of Z as a real. So here, generator will try to generate the X prime as a real input, and here it is a maximize this function to classify this real as a real and this X prime generated by generator as a fake. So that is both are beating each other. Okay, so that concept is used to generate the new contents. So this is your two network are trained with the minimum max optimization game, and this is given by this equations. A minimum of G and the maximum of D by the this logarithm scale of this equations by this equation, and this is the P data of X is the real data distribution in the prior distribution over the written space. D of X is the probability that X is real, and the EX equal to your P data of X is the log of DX. Encourage the discriminator to classify the real data correctly by the maximize the log dx, while EZ is given by this part. Encourage the generator to improve its output such that the discriminator cannot distinguish between the real and generated data. This is the algorithms, or this is the structure that is used in the I can say it is a generative adversarial networks. Okay. So this structure is used in the generative AI. So GN are highly effective at the generating the high resolution sample, but suffer from the scanning instability and the mode collapse, where the generator produce the remitted variation instead of the diverse samples. Okay. Now to solve this issue, the solution is given by the sustain a gen, that is the non-aerial WGN, mitigate this issue by optimizing the sustain one distance, which is a non-aerial WP data, comma PG, between the distance between the real data distribution and the generated data distribution, which is computed by the this equation, where the uh, this what do you call this set is non-aerial set of all point joint distribution gamma x comma y whose marginal are given by the p data in the pg, and gamma x comma y is joint probability distribution over the real and generated data sample, defining the how mass is the transform from the one distribution to the another. So this is a one kind of the model, that is a WGN, to reduce the distance between the real data and the generated data. Okay, and that will solve the issues of the GAN model, that the training is instability and the mode collapse are solved into the WGN. Now, as you know, transformer-based generative models discussed already last time, yesterday. That is in the large range models, transformer models. Okay, so there are the two kind of the transformer model. Transformer model have ability to process the sequential data efficiently using the self-attention mechanism, which allow the model to capture the wrong range dependency. Mainly two model, the decoder only model that is used in the GPT, and the encoder decoder model that is used in the BLT large language model. The decoder only model, they use the given the input sequence X, the self attention mechanism compute the output as this given by this one, where the Q, K, and V are the query, key, and value metrics derived from the input embedding, and decay is the key dimensionality. So yesterday I talked about the this equation, and I also talk about the what is the self attention, multi-head attention. Then it is a, group query attention, and what is the benefit of this? Okay, this mechanism enable the model to weight contextual informations from all the position, and when appropriate marks ensure the casual generation. Okay, so based on the context, so this transformer based model will use because of the this nature of the decoder and encoder transformer based generative model, it is possible to generate the new contents based on the contextual weighting of the information and the position, and the when it should be the mass and when it should be the use the your attentions. Now this is the your on in decoder only model. So, yesterday I talked about the this activation function also. The generation process with the auto-regressive manner. Auto-regressive model where the model predict the each token based on the previously generated token. The token-wise predictive distribution is given by the this equation. That is the probability of x of t given the x capital X is less than t, and it is equal to the activation function softmax into W into HT, where HT is the hidden state at the time t, and W is the output projection matrix. At the same way, the models train using the maximum likelihood estimation by minimizing the negative likelihood of the observer sequence. So this is the equation by the MLE, and this model only model in the case of the GPT. In the case of the GPT, this model are well suited for open-ended generations, but relies solely on the previously generated token for the context. Okay, the chat GPT, okay, it is suited for the open-ended generation. Okay, but relies solely on the previously generated token for the context. If the any token are not generated previously, then the chat GPT output is not giving the new content in the context of the generative EAs. If the token is previously connected, then this chat GPT can be okay, and this model is okay. Okay. Now, at the same way, in the encoder decoder transformer model, there is a BERT. It is a more flexible architecture for the conditional generator task. The encoder transformer the input sequence X into the contextual representation to the multiple self-attention and the feed forward that I discussed the last time. Encoder decoder transformer model. Why we have the encoder decoder? Okay, so this encoder transfer the input sequence X into the contextual representation through the multiple self-attention and the feed forward layer. Okay, MHA, multiple head attentions, and then it is a feed forward layer which is at a part of the encoder, and the decoder then generate the output sequence Y, one token at a time, one token at a time, attaining the both its previous output and the encoder representation via the cross attentions. Okay, so this condition probability of the generation each output token is expressed by the probability of yt given the y capital Y is less than t comma x by the softmax function of the w dot h, and with the training again based on the MLE, minimizing the conditional negative log values given by the as is given by the minus sigma t equal to 1 to capital T, and the log p given the xt given the capital X is less than t. And this model are effective in the tasks like the machine translation, summarization, text-to-text generation, where the output must be conditional on a external input. So here, for a given input, you can get the generate the new kind of the generative AI contents. Okay. Now, another model is the diffusion models. Diffusion model is what? Adding the noise during the encoder and the decoder. It is removing the noise. Okay, that kind of the concept is used in the diffusion model. The diffusion model generate the data by iteratively. In this case, encoder, decoder, or transformer made, it is not. There is no iterations. Okay, in the large scale model. Okay, it is not iterations, but in the diffusion model, it is having the data is generated by iteratively refining the Gaussian noise sample through a learn reverse stochastic process. Through the learn reverse stochastic process. So during the forward pass, it will learn the some nature of the data by adding the some noise, and in the reverse process, okay, it will remove the noise and generate the new contents. That kind of the thing is done in the diffusion model, and it is by iterations. The forward process progressively collapse the forward process progressively collapse with the Gaussian noise a data sample over the time capital T time step, and the degradation is a model at the first order Markov chain where each state depends only on the previous ones. Okay, and the transition probability from the xt minus 1 to the xt at each time step is defined by the this equation q of xt given the xt minus 1 equal to normal distribution is given by the xt 1 minus beta under root 1 minus beta t xt minus 1 comma beta t in I, where xt is a noisy version of the input at time t and xt minus 1 is the previous step in the forward diffusion process. Beta t is a variance scheduling that control the amount of the noise added in the each time step, and I is the identity matrix. Okay, So this is inferring the asymptotic Gaussian variable. Now in the reverse process, in the reverse process, which is run by, so in this diagram, this is the forward pass and this is the reverse pass. In the forward pass, adding the noise, Gaussian noise, and the reverse pass, we are removing the noise. Okay, that kind of the model is the diffusion model. The reverse process, which is run by the model, remove the noise step by step, and is modeled as a Gaussian transition given by the same kind of the distribution. Okay, uh, uh, so here the p of theta xt minus 1 given xt are given by the normal distribution of the xt minus 1 and then mu 0 and the covariance. Mean of the xt of t and it is the covariance of the xt minus t. So during the training and the model optimize the loss function that measure the how well it predict the original data from its noisy versions. The standard objective function minimizes the difference between the true noise and the noise estimate by the model. Well, this is given by the objective function is the minimize the this difference, true noise and the noise estimate by the model. So here in the diffusion model, we are making the estimation noise, and this estimation of the noise will help to generate the new contents. Okay, the diffusion model provides the high quality and the stable generative capability, but require the computationally intensive sampling due to the iterative nature of the denoising process. Only here it is having the high computing process because of the iterative kind of the process, which is not in the case of the transformer based models. Okay, so this is your denoising model, and so these are the uh, 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 model are used in the generative AI. Okay, one is the VAE. Okay, one is the VAE. Second is the GN, generative adversarial network, and then it is the fourth one is the transformer models, and the last one is the diffusion model. And still in the hybrid model, combination of this four. It may be the VN, GN with the diffusion model require the iterative refinement, and then it is a transformer. So combination of this architecture will also known as your generative AIs. Okay. So this is your hybrid architecture, VAE and GN. So whatever the benefit of the VAE and whatever the benefit of the GN are combined and make the new content, generative content are well in the different contents. Okay, so this is your this hybrid architectures of the hybrid AIs. Okay, and this is your diffusion gain hybrid model. Diffusion and the gain hybrid model. So this is your this idea about the stabilize the training and improve the sample diversity. And hybrid model benefits from the structure written representation of the VAE and the high fidelity generation capability of the gain and the stability of the diffusion model. So here, whatever the good positive point of the this all this new model, VAE, gain, and the diffusion model, all are combined to make the better generation of the AI contents. Okay, making them useful for the application require the high quality and realistic synthesis data generation. Okay, now you have seen the videos, ne? Political videos. I'm not putting the name. Okay, so it just look like the real. A real, if you just see that generated videos are not at the that levels. Yes or no? So now because of the this model and the combination of this model, you can create the new creation, and that is your generative AIs, and provide the improved performance, training stability, and sample quality, and making them suitable application requiring the high realism and the robustness. Now, okay, for the social media point of view, if you make the videos, images, but it is not a actual use of the generative AI. Okay, video making the new kind of the new kind of the content in the text, image, and the video are not a proper application of the generative AI. Now I am now speaking. Okay, this speaker. Okay, if the speaker will able to generate the content delivered by me in the different way, okay, then it is a benefit to the society. Okay, whatever I speak from the last 2.5 days, this third day, okay, so this is taking the data, either my data, and the speaker will give this device will give the new kind of the content which is delivered to the participants, or maybe there's some another participants. So that kind of the thing is made in the generative AI. Now, in the same way, mm, suppose that your model are well trained, okay, and if you have to find out there is a in the morning minority class and the majority class. Okay. So at the time, with the help of the generative AI, if you use the generative AI, then the minority class data are by using the minority class data, we can make the produce the new contents based on the minority class, and it is equal to your number of the samples in the your maximum class point of view. So your efficiency or your accuracy will be the improve. Okay, so this is a kind of the benefit of the generative AIs. These are the application of the generative AI in the health scale and the biomedical research. Generative model are all the model are used. Okay, and other than the new modified model AlphaFold and the EFN fold, use cases are the medical image super resolution, low dose city reconstructions. Okay, drugs discovery, protein structure predictions, and the impact and the benefit is the MRI fidelity, faster drug discovery, accurate protein folding pathway, NLP and next generation by using this model, text generation, machine translation, summarization, conversation AI, and more coherent text synthesis, multilingual capability, improve human AI interactions. Then there is the computer vision and the image synthesis using the generative model, GAN model, and the different model are used here. Image synthesis, super resolution, text to image generation, 3D object generation, and impact and the benefit, enhanced image quality, realistic 3D modeling, advanced virtual content creation, and climate science and environment. So these are the just example of the application of the AI. Another application are in the aerospace and the space explorations by using the this one aerodynamic shape optimization, spacecraft designs, okay, autonomous navigations, okay, that will helpful for the more efficient spacecraft structure, improve mission planning, okay, enhance satellite imaging, art, music, create, and the industry. With the help of the generative AI, there is no need of the creator of, there is no music director in the future. Okay, automatically the tool will create the new music and the lyrics without the any human interventions. Okay, no anumeric, anumeric ne? No anumeric or no I don't know, I'm not good in the only few are known to me. Okay, so no anumeric, no Shankar Devan or what, Shankar Mahadevan, yes. Okay, so no need of this. Okay, generative AI use the or produce the all this content, art, music, creative, and it is a new content. It is not copyright. It is not copied from the others. Okay, it is a new content. Okay, uh, LLM augmented search engine, conversational search. Okay, a multi-turn query handling, grounded answer system. Even now the people are writing the novels, ne? Even by using the generative AI, no writers. There is no need of the writer. If you put, then the publisher will make the new novel based on this generative AIs. Okay, metaverse and digital twin technologies. Okay, metaverse and the digital twin technology. That is your different model, and this is your realistic 3D avatar. Okay, and then virtual landscape, interactive AI driven assistant, finance and the market simulation. So there are the different domain of the this architecture, GAN architecture, algorithm trading, risk assessment, and the fraud detections, security and the cyber threat detection, different type of the generative model, deep fake, Gen, vision transformer, VIT, forensics, GAN normally, and DC are the model, and it is used for the cyber attack simulation, anomaly detection, deep fake detection. And the impact and benefit are the proactive security strategy, stronger fraud prevention, real-time cyber threat detections. Okay, and then it is the challenges in the generative AI, ethical, societal, and economical. Okay, so here I will just discuss some of them. What is the ethical considerations? Bias and fairness in the AI generated content, this fake and the misinformation. So these are the key issues, and the challenges are the may reinforce the societal biases, leading to the discrimination in the automated decision makings. Okay, and the deep fake and misinformation, AI generated fake media threaten political stabilities. Okay, cyber security and trust in the digital context. So now many when you see the real, okay, at the time we have the one doubt whether this is true or false. Okay, during the flood, many buildings are collapsed. So sometimes we have the doubt whether it is a true or fake. So this kind of the ethical conditions are very much concern to the society. Then it is the intellectual property and copyright, which is the one of the most important key issue. Okay, when I generate the new content by using the what you call a generative AI model, who are having the IP right. Okay, so this is the one of the ethical key issue. Unclear legal ownership of the AI generated content raised the concern in the art, music, and the literatures. Okay, and then AI deployment in the safety critical system like aviation or the healthcare may cause the catastrophic failure without the interoperability and safety guarantees. Okay, then the social implication, labor market distribution and the workforce transformation, AI governance and regulation, cognitive and the psychological effect of the LLM uses, and the economic implications. That is your generative AI influence on the market dynamically, AI role in the market monopolization and economic inequality, barrier on the Gen AI, adoption for SME and the research unit. Challenges are the fairness in the bias mitigation, AI governance and transparency, workforce adoption and the reskilling, ethical media deployment, and the global AI regulation. Now this is one of the applications. There is one of the applications is the generative AI-driven digital twin in the healthcare. What do you mean by the digital twin? What do you mean by the digital twin? The digital twin is the what do you call the yes? Give me the mic to him.
It is like
You keep the that one also here.
okay. It is a prototype. Like we can make a whole system. It's like we can produce a whole system, but it is not in real life. It is like a virtual environment. Virtual environment.
Environment.
Yeah.
This is not a real digital twin.
Yeah.
Okay, suppose this is a mic. Okay, and if I make the this mic virtually, and the virtual component and the physical component both are connected.
Yeah.
Okay, and whatever the changes is occur at the physical point, it will connected with the virtually also, and whatever we have changes I have done on the virtually,
It
it
will
is
change.
affected into the physical devices.
Yeah.
So this is known digital twins. Okay, so it is what happened. The physical device are generated virtually, and the both the devices, virtual devices and physical devices are collaborative actions. That is a non-real digital twins.
Yeah.
And how this digital twin can be useful in the healthcare with the help of the generative AIs. Okay, suppose I have the heart problems. Okay, I have the heart problem. So many sensors are connected. Okay, so in this case, what happen? The whatever the heart is generated virtually in the some another environment, and both are connected and measure what kind of the effect will be on the persons. So that is known as your digital twins. Okay, and the generative AI is used to make the creation of the new kind of the data set by the virtual created component. Okay, so this is non-real generative AI, the digital twin in the healthcare. So this is your data medical institute or public database or physical twin. Here it is the person is created. Okay, and these are the data set, and with the help of the I will go to the next slide. Okay, are you able to see this figure? Huh? So here what happened? Some data are generated, collected physically, and some data are generated by the generative AIs. Okay. So here what happened? If your data is in the less number, so then with the help of the generative AI, the data will created by using the generative AI model with the of the particular type of the data. Suppose if I have the audio data are in the small number, then with the help of the this generative model, you can generate the more audio data for a specific disease. Okay, many diseases are classified or identified by the voice. Okay, so this kind of the thing are done here. Okay, so these are the what you call histopathology. Okay, so here also we can generate the same kind of the data with histopathology, and this is non-real data synthesis. This is a non-real data synthesis by using the generative AI. Now, in the same way, so this is your physical component of the body. Okay, human body, organ, tissue, and the same. And same part are developed in the digital twin. That is the human digital twin, organ digital twin, tissue digital twin, and digital twins. Okay, so this is your case where the what kind of the effect in the environment. Okay, suppose this organ, if I put into the very noisy environment, so what kind of the effect on the heart? So that kind of the thing is consider. You can look at into the digital twin generated by the generative AIs. Now, in the same way, this will help in the various medical diagnosis. That is the your prediction, classification, abnormal detection, and the segmentation of the disease. And this will help in the precision medicine, medical communication, and surgical robot. Okay, a surgical robot where the human can able to what you call control the unseen what you call unsaid conditions. Okay, something is based on the experience of the doctor. If the anything unseen action is taken place on the patient, then the doctor can take the decisions what to do if the any wrong practice is done in the patient. But in the robot how to identify? Okay, robot will do only when the step by step process, but the actual or unseen condition cannot be handled. So if you want to do to put into the that kind of the scenario, then it is possible to with the help of the generative AI and the digital twins. Okay, then and then only you can make the surgical. I can the surgical robot without the doctor. The robots will handle any kind of the situation of the patients. So sometimes what happens, the patient condition will be the earlier before the operation is look okay, normal, but during the starting of the or midway of the surgery, the condition of the patient will be the critical. So how the robot will can be handled, that can be possible with the help of the generative AI and making the digital twins of the surgical robot. Okay, e-health service, telemedicine, and personalized treatment. This is the case about the generative AI driven digital twin healthcare. Now, in the same way, this is your generative AI driven digital twin in industries also. So here, what happened? The the process instrument component of the industry. Okay, there are the many physical components, many process part are converted into digital twin by help of the generative AIs. And then we can get the idea about the prediction of the accuracy of the product, yield of the product, all such kind of the thing can be possible. And the uh, minimum fault, okay, minimum use of the resources, a minimum raw material, all kind of the things can be possible if you connect the industry with the digital twin and the generative AI. So here it is regarding the manufacturing fault detections. Manufacturing fault detection are having a connect. It is made of the GAN networks, non-faulty sample, and this is the physical digital data generated sample, and with the help of the uh, generative adversarial network, you can get the idea about the what you call train discriminator networks, whether the it is a faulty or not faulty. Okay, any product is a faulty or not faulty. Okay, so, there are the two-way external fault and internal fault. Okay, so how we can identify physical fault can be identified by the inspections, and for the internal fault, it is very difficult to identify. We have to go through the series of the actions to identify the internal fault of the any product, any manufacturing product. So this will create the digital twin that will create the perform the internal operations inside the product, and that will identify whether it is a faulty or it is a not faulty. Okay, so this kind of the thing is possible because before experience to the real world and experience by the person, then after the fault, if it is identified, if I purchase the laptop a new one, okay, it's look okay, but when I used for the 1 or 2 day, then my laptop will be not work well. Okay, so this kind of the thing will be the generate the uh, 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 generate the question on the branding of the that particular product laptop here. Okay, so here the with the help of the generative AI, whatever the phenomena that can be the generated in the digital twin, and it can be classified whether the this laptop will be the faulty or not faulty. Okay, so this is the just example of the manufacturer of the laptop, complete laptop. Okay, so this kind of the thing is possible with the help of the generative AI and the digital twins. Okay, so that is the help of the generative AI is not for the only video and the image or only for the reel. Okay, this is a many application with the generative AI in the different sectors. Okay. Now this is a quantum computing. I will discuss the quantum computing in the Friday. Okay, it will take the more about the 30 to 40 minutes to discuss the what is the quantum computing, because we are knowing the conventional computings. Okay, we know the computer computing, cloud computing, everything. Okay, so this is your quantum computing is another category of the computing that I will discuss the next time on the Fridays. Yeah, any question? Now, everyone, we will share the Google Drive by today, and before the on the 19th September Friday, so before the 9:30, you upload your presentations. Team only one presentation per group, and this presentation will contain the three slides. Every member of the team will present the one side. Okay, madam? Yeah. Okay, so and it is the maximum we will provide the 3 minutes. Okay, just give your name, what is your name, and start your presentations. Okay, because we want to take the at least more than 20 to 23 presentations. Okay, and we have only 1 hours for the this presentations. Okay, within 1 hour we will complete our presentation of the all the student, and then after Friday I will take the 1 hour lecture about the computing, quantum computing, because this is quantum computing is the need of the India. Okay, that's why the mission computing are launched, and we need the contributor in the quantum computing. Very difficult concept, but we have to do something on the quantum computing. Okay, thank you.
Thank you, Professor Gautam Makwana, for this insightful lecture. I sincerely thank Professor Anu Gokhale and Professor Gautam Makwana for today's insightful lecture. With this, we conclude today's sessions of the Gyan Artificial Intelligence and Machine Learning. Thank you all for your participation, and we look forward to meeting you tomorrow.